Okay, hello. My name is Forbes. I'm going to be talking about powering code reuse with context and render props. And first, just thank you to our sponsors for having us here. So first of all, I want to talk to you about functions, and particularly functions being first-class values in JavaScript, and what that means for code reuse. And I'll start by talking about JavaScript in general, then we'll tie it to React specifically. So if we consider two functions that are very similar, the first of these takes an array of numbers and doubles each value in the array. The second of these takes an array of numbers and triples each value in the array. Hopefully, most of us would see this and not want to write out both these two functions as separate functions and have them live in our code base, because we can see there's only one thing that changes between these two functions, and that's the number that we're multiplying them by. So we can combine them into one function that simply takes a second parameter for the amount we want to multiply by, the factor we want to multiply by. So in that way, parameters to functions allow us to reuse our code more easily. But then we get a slightly more complicated example. The first of these functions multiplies each value in an array by a factor. The second increments each value in the array by some number. And because of that, we've no longer got a simple number that we need to pass to parameterize this. We've actually got two different operations, a multiply and an add. Again, hopefully no one in this room is going to sit there and want to write out these two functions and have them live separately in their code base. And we could look at this and say, okay, let's take a third parameter that's what operation you want to apply and can be either add, multiply, subtract, divide. But we can jump ahead a few steps and imagine all of the different operations you might want to apply to some value in an array. And there needs to be some way that we can represent all of those possibilities in one go, rather than just having an explosion of arguments and having hundreds of arguments for every possible thing you might want to do to a value in an array. So because functions allow you to take one value, or even many values, and transform them in an arbitrary way into some new value, we can use a function to represent this operation. So we reduce our code once again to one single function that simply applies a given function that you pass in to each value in the array. And of course, this exists as a built-in thing in JavaScript. It's the map method on an array. So I've talked about how parameters in JavaScript can be used in normal functions just to aid in code reuse. And now I want to talk about specifically React. Well, React properties are really just parameters. There's no difference between parameters to a function and properties in React. All of the same principles apply. So if you've got two React components that differ only by some small thing, then you're not going to write out two separate React components. You're going to write one and take as properties whatever changes between the two instances of that component. So I'm going to consider a concrete example now. This component called now renders the current time, the current date and time, in fact, and every 100 milliseconds it updates. So there's a fair bit of logic to this for such a small component. Because on mount, when the component is mounted, we need to start a timer. And on that interval, and I've set this to 100 milliseconds, we need to keep updating the state, keep updating for the current time. And then on component will unmount, we need to clear that timer, because if we don't clear the timer, then we've got a memory leak, and in fact, more like a runtime leak in our code. Because if we then add and remove these components from the tree lots of times, and we weren't clearing the timer, then we'd have all of these timers running in the background that were updating components that were no longer visible on the screen. So all of that logic is needed just to make sure that we're rendering regularly every 100 milliseconds to keep this date and time on the screen up to date. And then we've got a relatively simple render method that just says, take the current time, turn it into a string. Okay, I might want to change this in lots of ways if I wanted to use this component in my application. Maybe I'm dealing mostly with developers for my application, so I want to show not the current time in your local time zone, but the UTC time. So The change is very simple. I've renamed the component just for clarity, but the only real change is that in the render method, I'm now calling toUtcString instead of toString. So it's only this bit that's changed. If we want to use one component to handle both jobs, the obvious starting point is to say, let's just take a parameter that's a Boolean, or a property that's a Boolean, called UTC, and then we can use that property to switch between calling toUtcString and toString. Now, the problem comes when, just like with the first function, is what about when I change the requirements again? And maybe I want to render only the time, only the date. Maybe I want to format the date in some way. It's perfectly possible to continue this process and just add properties until you handle every possible case. But there's an easier way, and there's a more convenient way, which is to say, actually, all that's changing is the behavior of that render function. So why not just take a function that handles that logic for us? So we change the component slightly, and now instead what we do is we say, we'll call a property called render. We'll have a property passed in, and the value of that property will be a function, which means we can call it, passing it the current date, and whatever it returns, we'll just render that. So it can handle converting that date into a string. And then we can really easily build all of these different components without having to repeat that logic about on mount, start a timer, on unmount, clear that timer. And we can have local time, UTC time, local date time, UTC date time. And all of these are just formatting the date in different ways. They're just extracting different information from that same object. So all of these are doing a very simple thing. All of these are taking a date and converting it into a string. And you could be forgiven for going, what's new, what's React about this? There's nothing that's different to anything normally React-related. But what if I say the next requirement is, I want the date in bold and then the time not in bold? So suddenly, I'm not converting a date to a string anymore. I'm converting the current date time object to some kind of React structure, some kind of HTML. We could use a string and use like dangerously set inner HTML or something like that, but we're React developers and we can do better than that. So the output we want to generate here is a strong tag, and inside the strong tag is the current date, and outside the strong tag is the current time. Well, we don't really need to do anything to our code to our now component to get this, because already it has the render method completely just calling this function that we can provide. So instead of having to have some special format string that figures out which bit's in bold, which bit's not in bold, we can just pass a different function in as that render prop. So this time we call that now component, but we give it a function to render the current time that actually, instead of returning a string, returns a React element. So I've used React.fragment because we've got these two parts of this React component. The strong tag, knocked the microphone. We've got the strong tag and the actual current time. And then, I render exactly the JSX that I would want to render. And I don't need to think here about the time being and updating this every 100 milliseconds or any of that stuff. That's all handled by the now component. And this same principle applies for anything where you've got lifecycle methods or state, any of that kind of behavior that requires a React component to give it some context, to give it something to attach itself to the DOM. You can wrap up that logic in a component and still take render properties to customize the behavior in arbitrary ways. So the next thing, just a final note on this area, is that children is just a special property. So I don't have to give it a named property called render. I can literally just replace the word render with children when I define the component. So instead of render here, I have children. And then when I call it, instead of calling it and passing in a property called render, I can just directly pass the children a React component. It's still best when you're able to share code by just putting it in a function. If all you have is some code to, I don't know, answer if a number is a prime number or not, there's no reason to put that in some kind of higher order React component. Sometimes if you just need a function that takes some arguments and returns a value. But when you've got state and when you've got lifecycle, a React component is the way to go. And because you can take render props as arguments, you can still fully customize the behavior of that component. So I promised I was going to talk about context, and this is the part where I start talking about React's context API. But first I want to talk about state. So state is anything that changes over time. And state can be permeated throughout our application. Some state lives locally to a component. Whether some accordion is expanded or contracted, that can just live within the component. Some state belongs in the browser's address bar, the URL, where the user has navigated to, which page they've got selected. That all lives in that navigation bar. And there's great tools for managing that, like React Router, which actually uses context behind the scenes. And some state is data that you fetched from the server. So anything you fetch from the server is state, but it's much more global state on the whole. You don't want you don't want lots of different sources of truth for what data is currently on the server. You want one central place where you go, this is what's on the server. So we think for now about local state. We start off with a big tree of components, and in one component, we've got some state, and I'll call that component A. Now we've got a second component called B that has the same state. So if we have two components that want to share the same state, the easiest way to do it is to take that state and move it up to the parent and have the parent keep track of the state, pass the state down to its children, and receive changes back up again. That all works quite nicely, but what about when we introduce a third component in some disparate part of the tree that also needs that same state? Well, we can stick with the same process. We'll move the state up to the first common child, a common parent rather, and at that point we'll store the state, keep track of that state, and we'll pass it down through the properties throughout our tree to our leaf nodes that actually use the state. The problem with this is all of these components that I've marked in yellow have to know about that state now. They have to know that their children require this state and that it comes from their parents. So we've got to modify all of them to keep that state in order and pass it through. Sometimes being explicit is the best option. Sometimes that's going to lead to the clearest, easiest to understand code. But sometimes it's just boilerplate, it's just noise, and it's just getting in the way of good, efficient software development. Okay, let's return to the problem we started with, which is there's three components in disparate parts of the tree, and they all need to share some state. You might think at this point, let's use some kind of external store. There's things like Redux, Flux, loads of different technologies for creating some kind of global store. But we really don't need something that heavyweight at this stage. What we really want to do in many cases is just move the state to that first common parent. So we'll keep the state in that root node, but what we want is some way of passing it from that root node into the leaf nodes that consume that state without having every single component in between those two have to be aware of that state, and that's what context lets us do. So context allows a provider, potentially, in this case, the root node, to effectively beam state into the rest of the tree beneath it. So in this example, we could say the root node has some state, and it provides it to the entire tree, and then throughout our application, we can access that state. But one of the nice things about context is it doesn't have to be that way. So you can use context even for subtrees of your application. So we can have some shared parent here that beams state into part of the tree. And then we can also have another shared parent in a different part of the tree beaming state to a different part of the tree. And these could be the same kinds of state. They could be totally different kinds of state. You could use this for the current time, so that you make sure that all of the clocks that you display on your application are consistent. You could use it for theming, and you could have different parts of your application themed in different ways, and build out the same set of components, but in one color scheme for one company and another color scheme for another company, and show them side by side in the same application. And theming and data sharing in context, this is a really effective way of doing that. Okay, let's look at a more concrete example. So I mentioned theming. We can create context, and when we create context, we provide it with a default value, so that the context is going to capture some value for a part or a part of the tree of our application. So we give it a default value. So in this case, I'm saying that this defaults to black, and then we can consume that state just by rendering the consumer component from that context. Part of the reason I start this talk with render props and cover both of them in the same talk is that consumer uses a render property. So that's just a property we're passing in that happens to be a function. And all that the consumer is going to do is get the current state of that context and call our render prop to actually render the content. So the consumer itself doesn't have any DOM nodes. It doesn't render any divs or spans. All it does is call that function, take the result of that function, and return it. But it's calling it with the current state, with whatever state's been extracted from context. So in this case, I've made a themed circle component that renders a circle with a color based on the theme. So I can use that multiple times with multiple providers. So here I've gone for one provider that provides the value blue, another provider that provides the value red, and then some circles that are not in any provider at all. Now in this example, the themed circles are directly beneath the provider, but they can be any level of arbitrary nesting. There can be any number of components in between, and that state will always make its way from the provider to the consumer. And this will render, oh, we're missing one circle off the end, I'm sorry. There should be 3 white circles on the end as well. But it'll render as a set of blue circles, red circles, and white circles for each of the different contexts. The great thing about the context API, the new context API, which is new in React 16, is that this context API has a pair of provider and consumers generated by that one function call, which means there's never any worry of conflict between different uses of React context. So you can use it for your theme, you can use it for your routing and your navigation state, and you can use it for the state that you fetch from the server. And know that all of those things will be separate. You never have to worry about naming collisions or anything like that, because it's not the fact that I've called this color that matters. It's the fact that it's this particular instance of a context created by React create context. Okay, so another example, if we have state that we want to share among multiple components, and we want those components to be able to update the state as well, we can simply include in the context a method for updating that state. So this time, I've said the default state is on some Boolean that's set to false by default, and an on toggle function, which the default implementation is just going to be a no-op. I can then create a function to provide that context that actually keeps track of the state. So I default the state to having on be false still, but this time on toggle is a function that sets that state and toggles that on to be true or false alternating. I then render the provider that's coming from React.createContext, and I pass in that state as the value. And then I render this.props.children inside so that I can simply use this as a component to wrap anything that I want to share the same toggleable state. I can then create a toggle button that simply consumes this context, and it'll be provided with both the on Boolean that is either true or false, and an on toggle function that swaps between those two values. So I can create a button that every time you click it, it toggles between on and off. And then if I render multiple of those within one toggle provider, they'll all toggle on and off together. So they'll all start off, and if I click any one of them, they'll all swap to on. I can click it again, they'll go off and on, and so on. So they'll always stick in that loop of sharing that same consistent state. And I can render multiple of these throughout my application, and anywhere, and they're grouped by the tree that they're in. So I think I'm going to have been a lot faster than I planned to be, but I'm going to now run through a brief summary. So functions being first-class values means that we can use them as parameters to enable flexible code reuse. So instead of just having booleans and strings and numbers to control how our code varies across multiple instantiations and multiple calls, we can have functions that allow us to be very flexible. So using functions as properties on React components allows us to share components that consist of lifecycle and state management, and have those components shared throughout many different uses that might actually render very different things. And we can use those properties that are functions potentially to change what gets rendered, but also to change other aspects of behavior. Functions are just values in JavaScript. So React Context lets us share state across either the entire tree of our application or parts of that tree. And because context is still using the React tree, we can still render our code server-side, and we can safely use it for parts of our application, as well as just using it for the whole application. So if you were using instead a singleton separate store, then anytime, then you're kind of tied to that one instance of that store. So if you want to reuse a whole tree of your application that has some shared state in some singleton store, then anytime you reuse it, you're going to be sharing that same reference to the store, and you've got suddenly a big job to refactor it if you want to break out of that model. So context lets you share things like that. And the other thing that context handles is if you are using it for only parts of your application, for parts of the tree, then you can rely on the built-in garbage collection that JavaScript and React provide, so that when those components are unmounted, the state that's stored in that provider will also be destroyed. Whereas if you have an external singleton store, then it's up to you to manually dispose of that store if it's no longer required. So my Twitter handle is @ForbesLindsay, so feel free to follow me there if you want to follow any of the work I do in JavaScript. I try and tweet whenever I publish new open source libraries and whenever I'm planning to go to conferences and things like that. And thank you. I think we've got lots of time for questions, hopefully.
Any questions for Forbes? Maybe during the coffee break. Thank you, Forbes.
All right. Thank you.